Hello everyone. The topic I am going to discuss is about microwave drying. In previous topic, we have discussed about radio frequency heating, its principle, its working principle, its difference between radio frequency and conventional heating, the advantages, disadvantages, and applications. In this topic, we are going to discuss about one of the non-ionizing radiation, which is microwave drying and infrared radiation. Microwave drying, it's a form of electromagnetic radiation with wavelengths ranging from about 1 meter to 1 millimeter, corresponding to frequencies between 300 megahertz and 300 gigahertz respectively. They have both an electric and magnetic component. Electric component is responsible for heating. The dielectric materials such as food, wood, paper, etc. absorb microwaves and get heated. Microwave cause the food to heat rapidly, whereas gamma rays with much shorter wavelengths and higher frequencies, it penetrates the food so rapidly that little or no heat is produced. For this reason, food radiation is often referred as cold pasteurization. Conventional methods: it alters the flavor, color, and texture. Federal FCC, Federal Communications Commission, it recommends two frequencies, which is 2450 and 915 megahertz. Among these two, 2450 megahertz frequency is used for home ovens and both are used in industrial heating. Microwave drying. Microwave drying, it offers to shorten the drying time without degradation of final quality of the dried product. Food material is heated directly due to agitation of the polar molecules contained to it. Microwave drying, it utilizes very fast volumetric heating. Principle: two principal mechanisms that explain heat generation in a material placed in a microwave field. They are dipole rotation and ionic polarization. First, dipole rotation. Food materials contain polar molecule like water. They have random orientation. When an electric field is applied to the molecules, they orient themselves according to the polarity of the field. In this microwave field, the polarity it changes rapidly. The rotation of molecules leads to friction with the surrounding medium, resulting into heat generation. Then about ionic polarization. When an electric field is applied to the food solution containing ions, the ions move at an accelerated pace due to their charge. Because of this, collision happens between the ions, which causes the conversion of kinetic energy into thermal energy. Thus, these are the two principles: the dipole rotation and ionic polarization, which happens in microwave processing. Major components of microwave oven. There are four major components of microwave oven. One is magneton, transmission section, stirrer, and an oven cavity. Magneton. It is the electron tube within a magnetic field capable of converting power supply into microwave energy. Power output in kilowatts. For domestic ovens, it operates at frequency of 2450 megahertz. For transmission section, they transfer the generated energy from the magneton to oven cavity. Here, energy loss is less. Stirrer. The stirrer is usually a fan-shaped distributor that rotates and scatters the transmitted energy throughout oven. The stirrer disturbs the standing wave patterns and allowing better energy distribution in oven cavity. The oven cavity, it encloses the food to be heated with metallic walls. The distributed energy from the stirrer is reflected by walls and intercepted by food from many directions with more or less uniform energy. The energy impinged on the food is absorbed and converted by heat. Mechanism of microwave drying. The mechanism energy is mainly absorbed by liquid water present in the food. The microwave energy. The absorption of microwaves, it results in the temperature to rise. Some water gets evaporated and the moisture level decreases. Internal heating and evaporation of liquid water takes place inside the food material and generates significant pressure. Moisture is pumped to the surface due to pressure gradient. The resulting pressure driven flow becomes an additional mechanism of internal moisture transport. Types of microwave drying. There are two types: microwave convective drying and microwave vacuum drying. A combination of hot air and microwave energy is microwave convective drying. It is used to improve the heat and moisture transfer. It levels the temperature and moisture profile within the product. Then about microwave vacuum drying. It is an integrating microwave energy and vacuum. Food gets dried quickly at low temperatures due to rapid energy transfer by microwaves and fast mass transfer conferred by vacuum. The absence of air during drying inhibits oxidation. It results in lightweight dried products that retain their original flavor, color, shape, and nutritional qualities. Advantage: it provides rapid drying at low temperature. The thermal efficiency is high, and the bed is stationary so that it avoids problems of dust and attrition. The endpoint granulation, it can be directed by measuring the residual microwave energy. Limitations: Non-uniformities in the microwave field and associated heat patterns, it leads to non-uniformity in drying. Corner and edge is over dried. The problem is that drying of thicker materials due to lower penetration depth of microwave, that is, it can't penetrate thick materials. It has the there's some possibility of damage of food texture due to too rapid mass transfer. It has high startup cost. Microwave applications. In tempering, it is used in meat, fish, and poultry. Or there are various microwave processes like tempering, cooking, drying, vacuum drying, freeze drying, pasteurization, sterilization, baking, roasting, blanching, rendering. And the products used are bacon, meat patties, pasta, onions, orange juice, meat, fruits, vegetables, bread, pouch packets, bread, nuts, grains, vegetables, etc. These are the various applications used in microwave processing. Thank you. In the next class, we will discuss about infrared drying.